Welcome to The Explainer. Today, we're diving into a bit of modern magic. We're talking about how to coat almost anything, plastic, glass, you name it, with a perfect, shiny layer of metal. But here's the crazy part, without using any electricity at all. So, let's kick things off with a puzzle, one that has totally changed the game for modern manufacturing. Say you need something to have all the good stuff from metal, strength, conductivity, that nice resistance to rust, but you need it on a material that's super lightweight or flexible or has a really complex shape. You know, like plastic. How on earth do you pull that off? Well, the answer is a process called electroless plating. And trust me, it is a hidden technology that is absolutely everywhere. It's the secret sauce that makes the tiny, complex circuits in your phone work. It's why cars can have parts that look and act like metal but are light enough to save on fuel. It's even critical for making advanced medical devices that are both super strong and safe for the human body. Okay, so how does this chemical wizardry actually work? Honestly, the best way to get your head around it is to stop thinking about complex chemistry and start thinking about it like cooking, but in an incredibly precise form of cooking. We're basically creating a special chemical bath that's going to cook a layer of metal right onto a surface. Now, the absolute key ingredient in this whole recipe is a concept called autocatalysis. It sounds complicated, but the idea is simple. It means that once the reaction starts, the metal that gets laid down becomes the very thing that kicks the reaction into overdrive. It's like a chemical chain reaction that just keeps feeding itself. Right, don't let the equation on the screen freak you out. In our little chemical kitchen, here's all that really means. We start with a liquid solution that has tiny metal ions floating around in it. In this case, it's nickel. Then we add a reducing agent. Think of that like the heat from the stove. It provides the energy to turn those dissolved metal bits into a solid, pure metal coating that sticks right onto our object. The whole process is just elegant. First, you activate the surface of the object with a catalyst, creating these tiny little hot spots for the reaction to begin. The very first metal atoms latch onto those spots. But then, and this is the cool part, thanks to autocatalysis, that brand new layer of metal becomes the catalyst itself. The reaction just takes off, growing a perfectly even coating over every nook and cranny, no matter how complicated the shape. Okay, so now we're moving from a simple home-cooked meal to a 5-star gourmet dish. To really control this powerful reaction, chemists use a whole bunch of special additives. You can think of them as the secret spices that a master chef would use. And let me tell you, without these additives, the whole thing would be a disaster. The reaction might just go wild in the liquid, creating a bunch of useless metal dust. Or the coating could come out all clumpy and just peel right off. But with the right additives, you get a stable, long-lasting bath that gives you a smooth, strong, and perfectly bonded metal coating every single time. Each one of these spices has a very specific job. You've got ligands, which are like chaperones at a dance. They hold on to the metal ions and only release them when the time is right. Inhibitors are the brakes. They make sure the plating only happens on the object and not just randomly in the bath. Surfactants are like emulsifiers, keeping everything perfectly mixed. And then you have these fascinating bioadditives that can act like a molecular superglue, helping the metals stick to really tough surfaces like plastics. All right, so we've seen how this clever chemical trick works, but now let's look at how it becomes a manufacturing technique with a level of precision that is, well, it's almost hard to believe. We're talking about control at scales you can't even see. And this isn't just for putting on thin, pretty layers. Some of these advanced chemical baths can build up really thick, tough coatings at some pretty impressive speeds. We're talking 20 micrometers an hour. To put that in perspective, that's like adding a layer about a quarter of the thickness of a human hair every single hour. This is how you create super robust protective layers for things like engine parts or heavy-duty drilling equipment. But honestly, the real jaw-dropping breakthrough is what's happening at the nanoscale. There's an advanced technique that creates a self-terminating reaction. It perfectly plates a single layer of atoms, and then it just stops, dead in its tracks. This gives us the power to literally grow materials one single atomic layer at a time. It's incredible. So we have this incredibly powerful, super precise technology, but it isn't standing still. As it gets more and more precise, it's also evolving to become much more sustainable and a whole lot friendlier to the environment. And this slide really nails the shift in thinking. Researchers are actively swapping out harsh, traditional chemicals for greener options, things like glyoxylic acid or even amino acids. And get this, instead of just creating waste that's hard to deal with, the new goal is something called valorization, which is a fancy way of saying they're designing the process so that valuable metals, like nickel, can be pulled out of the used bath and recycled right back into the system. It's a closed loop. And all of this leaves us with a really fascinating thought to chew on. Electroless plating is this amazing technology that lets us blend the properties of totally different materials in ways that just weren't possible before. So as it gets even more precise, more sustainable, and more versatile, what kind of new innovations are we going to create? What becomes possible when we can effectively grow smart materials atom by atom onto any surface we can possibly imagine?